Start recording. Well, welcome everybody, and we're going to do a online training today on doing a custom shelf. So the way this worked is we've got a bookshelf here that was just built, a nice bookshelf, and we want to put a printer on it, and the printer's just not quite big enough. I'm sorry, the shelf isn't big enough for the printer. So we're going to use our ShopBot and design a custom shelf that will accept our printer. So let's kind of take a look here first at the scenario at hand. We've got this beautifully cut bookshelf on the ShopBot, and now we need to figure out how do we make a custom shelf that fits in there. We got to figure out the tolerances, the measurements, and get all that in there so it fits just right. Fasten it down, and then have it so it'll fit our printer. If the printer wasn't on there before, it would have, if the shelf, it would have fallen off. So that is Al, and he helped me with this project. And let's go ahead and get right into it. So that's what we're going to look to be building. Simple, right? Is it a simple shelf? Yeah, I guess you could look at it as simple, but it did take a couple hours to make, and it would be something very custom, one of a kind, that you could definitely charge in your business and make some money from. And then here's the file we'll look at. We're going to have a 4-foot by 8-foot table. We're going to have our glued up blank, and then we're going to have the final piece that we have to draw and get that to its custom size. It's a pretty custom size shelf. That would be something that would be kind of a trick to do by traditional woodworking. So let's get right into it. So we got these new shelves, and they look great. However, Al couldn't mount his printer on this because half the printer hangs off. So we would need to, at this point, build something up. So this would be maybe a customer would call you or find you on 100K Garage and say, hey, I need some custom CNC work. Then I came into the picture and said, all right, let me measure this opening. So I would measure the width and the length. They got the little cutouts around the corner. And then just record this. This is just a simple drawing I'm putting down on paper, just a napkin. I put the printer back up on there to figure out how wide it needed to be. And then you got the little corners right there you got to get around. The thing we got to think about is tolerances. We've got to think about how do we cut a square edge with a round bit. So a custom shelf can actually take a little bit of planning to go into it. So there's the drawing. There's just my quick sketch. So I just sketched this out, and then to go and glue up all that maple and cut it out and have it be wrong, I would have a problem with that. It would be a waste of material and time. So once it's drawn into the VCarve software, the first thing I did is I went and found a piece of cardboard or a scrap piece of MDF or something, and I threw it out here. Here's out on our back machine. So this machine's got 8 different tools, and look what it's doing. It's doing a tool change. It's dropping off the 1/4-inch end mill and going over and getting the 3/8 end mill. So this one is very nice for our production setting, so we don't have to have a guy standing there changing bits all day long. This one will sit there and change the bits throughout the file. So I just changed the bits, and then it's going to prompt me over on the computer to come over and make sure I hit the green go button on the control pad and then hit enter or click with the mouse on the computer, and then it'll start cutting. So this is a quick, easy way for me to make sure my measurements are right before I go out to cut it out of the sugar maple that just costs $3.50 a board foot. So, and this is nice too because it has a vacuum table on it. So you're seeing me be spoiled by day, and then later on in the series I'll show you another machine where we don't have tool changers and vacuums, but it sure is nice. I'm not gonna lie. And then just come back to the setting if and double check it. This would be cardboard. If you don't have cardboard, MDF, something cheap, something that you can put in there and see. Make sure it's going to work. Make sure it fits. It's snug. Make sure it'll hold the physical part that you're trying to do with it. Put it up there. Make sure it's deep enough. So yeah, I don't have to have it any distance in the back because the cords come off the side. It's suspended. I don't go out any further than I have to. So I would be happy with that. So that's a good thing to do first, is just make sure that it fits before you go and spend some time with the wood. All right, the next thing I got to do is order up some wood. So the bookcases were all soft maple. So I said, all right, I got to match the grain. So I went and bought some soft maple. Here you can see where I'm pointing out alternating the grains. If you look at these, you can actually see the cut in the tree, the way it was sawn out of the actual tree. And you do want to alternate those up and down each board. If you don't do that, what you're going to end up doing is cupping that whole panel will be either a big smiley face or a sad face. So I try to stay under 6-inch wide pieces and hide your knots and your imperfections on the ends if you can cut around them, and dry clamp it up here and make sure it's going to fit before you put glue. And then when you're gluing up panels, again, it's nice to have them labeled like that, because I start flipping these around, I'm going to forget which one was which. So I've checked them for grain, I've checked them for the way the twist is on them, and I've laid them all on there in a way that it's going to be as flat as it can be with gluing up. And then right there, the ShopBot itself works as a great bench. Especially in a small shop. There's a 4 foot by 4 foot half right there that I know is perfectly flat that I can glue off from, and it just works as a nice bench. When you're gluing edge to edge, which is this type of joint that we're doing, you got to put glue on both edges for it to work, and you want to spread it out with your finger. You got to make sure that entire edge is covered. If there's any wood that's left untouched by the glue, it won't actually bond right. So I like to lay them down, move them back and forth a little bit on each other's edge just to make sure that they bind up. Always been a Type Bond 2 guy. I just switched to this Type Bond 3, and I've really been enjoying that. It's been a good glue. You can do two things. You can either wipe it down with a wet rag, or you can let it harden and then scrape it off with a chisel. I personally like to wipe it off wet, then I don't have to worry about missing it and having that hard glue chip a cutter. Same thing with underneath. Whatever squeezed out on top is probably squeezed underneath, and also wipe it off your bench. And notice I didn't clamp very hard. I just got them snug and then gave them a little bit of pressure. And here I am alternating the clamps too. And the alternating the clamps helps you too from keeping that board or that panel from warping, twisting one way or another, especially if you get the thicker too. So there's just a simple glue up that I did. I had pre-ripped boards. I glued them up. I didn't do biscuits or dowels or anything because I'm going to be cutting in the middle of this, and it's not something that has to have those either. So there's the basic glue up. I got it over here on the machine now, and notice I've just pointed at a 1.5 inch gap that I have of the offset, and you're going to see that in the file. Why did I leave this in 1.5 inches? And you'll see that when we actually start cutting. So right now I'm taking more measurements. How big is this actual blank? I got to physically measure the blank and make sure I found that size. And now I'm feeling for high and low spots. So I found the high spot right there, and I'm going to mark it. And that's probably where I'm going to zero this first cut. And I bring that over there and zero it because I want to start in the high spot and go down. If I started in the lowest spot, I could take off too much. So here we are without a vacuum table now. So I'm pre-drilling these corners to where I'm going to run screws. And you can watch another training that we did on how to surface flat panels or warp panels and make them flat. And you can reference that if you're wondering why I'm not screwing this thing all over the place. I don't actually want to pull the twist out of this. I'm going to machine it off, something that you can't do with a planer. So there's a countersink bit. And with the countersink bit, it does my pilot hole, and it's also going to do a countersink on top that will allow me to put my screw head deep down in that I won't hit with the planer. I'm sorry, with the cutter. That's actually going to be down there about 3/16 of an inch, and I'm not going to take that much off. So that's a nice way to do it. If it's a smaller piece, you could always rip a kerf along the edge and the end grain with the table saw, but this works great. So I just screw the 4 corners, and I don't go out of the way to screw it down with a lot of pressure. I'm not trying to suck all the warp out of it. I want to plane the warp off. So you can always reference that video for more of that. But what you do want to do once you have this screwed down is then you're going to have to come over and zero it. So we're zeroed. Do your C3 routine, which would get your X and your Y, and then do your C2 routine, which is what we're going to do here for your up and down Z. And I'm going to bring it over to where I had identified the high spot. Sometimes if I do it to the low spot, the high spot's so much different that I'm actually taking off more than that cutter is able to do. That little cutter isn't designed to take off over, I believe, a 1/16 of an inch, and especially when you get into harder woods too. So note, if I had a panel that was 13 inches is what the width of my planer is, I probably would have ran it through there, because the way the planer action is, it's actually the way it cuts away from the grain is designed a little better than the way we're coming at it as a cross grain. But I don't have an 18-inch wide planer, and I didn't want to glue it in two halves and biscuit it in the center. So this works fine. You're going to see a little bit rougher of a finish cut because of the direction that we're coming into from the top. We're not curling it away, but there's nothing you can't sand out real quick. So use your zero plate, excuse me, get that in there. Underneath, make sure there's free of debris. Get your alligator clip over in your collet and go ahead and zero that out. So when we get done with this here, we're going to go into the file for making this surface. How do we create a surfacing file? So we're zero. The machine's ready. We just need to go get some files. I want to surface this thing and get it parallel and flat before I turn it into a project. So what I'm going to do first is start a new Vectric VCarve profile. And I'm just going to start up a brand new one and create a new file. And for this, it's going on a 96 by 48 inch machine. And since I'm going to be machining from the top, from that low spot, you just saw in the video that I zeroed it to the top of the board for this. Later on, when we do a different type of cut, you're going to see me zero to a different spot. So there's the overall size of the machine, and then there's how thick it is. Check that with some digital calipers, and I'm zeroed to the top. So the blank itself that you saw me measuring, if I was to actually draw that blank on here, the blank itself, I'm going to put it in the specific size, but also notice I had that 1.5 inches up off each corner. So I am going to give it an anchor point in that bottom left corner of 1.5 and 1.5. And the reason I'm going to do this is because when I start toolpathing this, I'm going to want to cut out past my wood when I'm doing this planing, because it'll help you with a better cut, and you'll see this in the next video. So I want to have my blank, which I measured 49 inches long and 23.5 inches wide. So that's the size of the blank. And when I hit create, it puts it here as 1.5 inches over and 1.5 inches up in the X and the Y direction, which is how it was in the video. And so if I was to right now just go and grab a pocketing toolpath and pocket this out, it's just going to pocket the inside of this. Well, I don't want it to do that, because when I'm doing a planing exercise like this, I like the bit to run all the way off the board on all four sides. When it slows down and stops and goes the other way, you've really lost your speed. So you're not cutting at the speed that you would be out here. So I'm going to run this out past. So if I'm going to be using an 1.25 inch diameter spoil board cutter, I'm going to make it a little bit wider than that, so the board will run off. So the bit will run off the board. So I can just come down here to the offset command. Say I want to offset this by 1.5 inches, and boom, there, it just made it a bigger rectangle. So if I came over here and said, all right, I want to pocket this bigger one, and the depth I'm going to take off on this, I think I only took about 30 thousandths on this first pass. And I use an 1.25 inch spoil board cutter. And you do need to know a little bit now about feeds and speeds with this. What kind of machine do you have? For me, I was cutting it with a spindle and an alpha machine. I was able to go 6 inches a second and 14,000 RPMs, and it cut great for that. Now, different material, different machine, it could be different for you. Offset or raster. Well, I know my grain is going back and forth along the X. So I really wouldn't want to use an offset because I'd be coming against the grain here and getting not as good of a cut. So I like it to raster, and depending on how you mounted it on your table, you might have to add a 90-degree angle to it. And then this is a profile pass. I like to do this last. The last cut, it'll go in here and cut all this out, and that last cut, it will come and do a profile all the way out, which is usually off the wood, but if you miss a little piece, it'll be right there. Not going to ramp it, not for this depth. We're fine with this. So I'm going to call this pocket shelf 0.03. And now I'm just going to step back and make sure everything's right before I hit calculate. Okay, so I'm happy with this. I'm going to calculate it. And now I'm viewing my different tool paths. I can see the blue, this is where it's cutting. I can see the red, which is it's traveling above the machine. And so I go to simulate this, and now it doesn't show exactly what's going to happen because I don't have a board that's that big. But me knowing what it's going to do, because I've seen it do this, I can check it in the 2D view, click on solid over here, and notice right there, everything in the blue is what's going to get pocketed, which is my board plus a little bit extra all the way around. So let's just show you the video of why that's bigger like that. All right. So here that comes over, and notice it's going to start move back and forth along the X with the grain. That's the type of tool I told it, the type of direction I told it to go. In a minute I'll zoom in here and you'll see why we have the overhang. The overhang is because that, I just measured this board with the tape measure and I got it close, but I also want to run that bit completely off the end, so when it does that move over right there, that step over, it's not doing that on the wood, it's out doing that in the air. So you can see where it's starting to hit and miss. It's not hitting all these spots. There's some lower spots there. So here it comes over. It comes out past, steps over, and then goes all the way down. Does that on all four sides. It actually hangs out past. But I'm going with the grain. Here you'll see the cutter hang out there, shift over, and then go back. I found when it does that over the wood, it doesn't leave as good of a cut. So now you're starting to see some hit and miss. There's some high spots and low spots. You're seeing along here. And for me, it was I'd rather run this file a couple times than try to go too deep and not get as good of a cut. So this file is a file that you can now continually use again and again. There's no need to go back in there, and I mean you could. There's no wrong way, right or wrong. You could go in there and just give it a deeper cut to now run over. But since I'm going to use this file again on this side, flip it over, and use it again on the back side, I can just do another C2. So keep an eye on the machine while it's running. There's that file progress indicator over on the left showing you. It's telling you how much time is in, your percentage that you're done. And when it's done, now I went and found the lowest spot of it, and I'm going to now C2 it there because I can run it back and forth and see there's not too much more to pull out of it. I had a pretty good flat glue up. That's not always the case when you get into big panels. I got a spot marked on my Z0 plate with an X, and I try to zero it in the same spot. I also try to hold it with my hand so it doesn't move, and you can feel it if it's going to move or not, or if it gets caught in that dust foot. But otherwise, keep your fingers clear of that bit when it comes down there. So turn on your dust collector, hit start, and just hit enter 3 times, and it'll bring up that same file, the last file that you just ran. And now it's making a consistent cut along the edge, and that's hanging over off to the side there. This works good. I mean, for doing big panels like this is really the best way to do it. If we could, and they make other cutters for getting different results and coming in from different sides. But for me to do it like this on a big custom panel, this is pretty nice. And any kind of bowed wood, it'll pull it out. I'm never hitting my screw. It's down inside there. With the planer, it pushes in the wheels and it just planes the warp. This one actually will plane out the warp, doing it like this. That's getting involved right there. So now I'm just going to flip it over. I made a line on my machine bed, pencil line at 1.5 inches over. Otherwise you could just measure again, but it's quicker to do that. And then I'm going to now countersink this back side as well, because I now need to make sure the screws are deep down on this side as well. And then finally, once I've got it held down, I would re-zero it, rerun it, that same file. I'll be running it now for the 3rd time, finding where is a good spot. I'm going for the lowest spot because I know there's not much warp or twist left on this piece, and it's already flat on the other side. So I'm just using the keypad to get it over that spot. Just see all that sawdust that blew out of there. Anything that's in there can throw off your zeroing. So again, is it that crucial for what we're doing right here? Not exactly, but it's best practices. Get in the habit. And then again, enter 3 times, turning everything back on and going. It's the same file. I just flip the board over, and I'm now doing it from the back, and it's going to be the same file running. Boom, starts right there. Does the back and forth with the grain. So when you use plain material and you cut down inside of material, you're going to find the grain does change down in there. So it's nice once you get done running this to pull the board off and take a look and make sure you get the best face. The shelf, like we did right here, you're only going to see the one side. The other side's pointed down and it's up against another piece of wood. So I'm not concerned about sanding and getting the other side perfect. I got it close by eye. But what I'm just doing there is evaluating it. I'm going to put a sander up on it real quick and just get it down to a finished quality and see which. I'm doing it over a couple of the glue joints just to make sure that it has the right grain that I want to it. And it's just me evaluating the wood, because once it's in place, it's in place. So just find the face of it that works best for you. You find some stuff when you start planing down into wood. So I'm lining it back up with my line. So now I'm going to have to go and make another file to actually cut out the shelf. I've got it to its thickness. So if you already had planed down material or glued up material, you're way past this point. You've already, you don't have to spend that time. But they don't carry maple at the Lowe's. So, all right. So at this point, now we need a file for this. We need a file that we can run, that we can make our piece on. So I know here's my piece right here, and if I wanted, I would save this as a separate surfacing file. If I ever wanted to come back to it, I could go save as custom shelf and go surfacing file. That way I've always got it if I needed to come back to it. But since I'm now not going to be surfacing anymore, I'm going to delete that toolpath and get rid of it. And over here, as far as what I'm going to do next, I would want to re-put my calipers on this and say, okay, how much did I actually plane it down? And I'm down to 0.74. And what I'm going to do now is, since I'm just doing a profile cut, I'm going to zero it to the machine bed. And you will see why in the video. Typically, for rule of thumb around here, getting started, is if you're going to, that's all you're going to be doing is a profile cut down to the machine bed. You're going to want to zero there. That takes care of any discrepancies in material thickness, which we shouldn't really have much after what we just did. But that's where I'm going to zero that. And then now I'd have to pull up that drawing that I had that was in the first video there. So I'm just going to draw it freehand here, kind of show you there's no right or wrong way, but this would be, the way I would attack this. I know that that first section of it is 40.5 wide, and it was 11 1/4 overall. And I don't have to draw it right in the middle here. I can draw this out in no man's land. And a lot of times I will draw out here and keep earlier versions of files. So, um, so from right there, I also want to create another box. So I can just go Control Copy, Control Paste, which is Control C, Control V, and I just put another box on top of that box. So you can see it's not this clear pink line. And what I'm going to do at that point is I'm just going to come in here off the top left corner, which is right here. I want to make this box same width, but I want to have it 12.5 inches. 12.5. And there, that's showing me how far it's going to come out where the corners are. And then finally, I'm going to have one more box. I'm going to do Control Copy, Paste. I want one more box that'll be 18 inches. And if you don't draw like this and you're getting stuff done, right on. Whoops, see there? I wanted it up here. So I'm going to go Edit, Undo. It's whatever works for you. You'll find your rhythm and start drawing in that. So I need to, by 18. All right. So this first one here isn't going to be the full box. We're going to have this step in 3/4 of an inch. So you could do that with the offset command if you wanted to. Right here, I can grab this one and offset it in 3/4. You could also come over and cut your lines if you wanted to. I could do a node and cut my lines. There's just different ways of doing it. So if I went and cut these all apart, then I could now come in here and just grab this and say I want to put an offset on it and offset it in whatever your distance was, which on ours measured 3/4 of an inch, 0.75. If you wanted to delete the original, you could. I don't. I'm going to leave that on there for right now. Oops, what did I do? Didn't need to check that. So there's that part. And so I know at this point my shelf cuts in, so I can use the scissor tool, and I know at that point that's where that cuts in. And then out here, I know this is the farthest distance that I want to come out, but from that point, I want to make sure I get that arc. I mean, we've got the CNC machine. Why have a straight line when we can cut a curved line just as easy? So I want to go over those vectors. It selects them, and then I'm going to bring this down, and if I hover over the center of that line, it'll snap right to it. So boom, go back to my scissors, snip away what I don't want, and there's that custom shelf. And another thing I always like to do is select all and hit join, or I like to select all and go select all duplicate vectors. I'm sorry. So there's the ones that were on there from before, duplicate vectors that are on top of each other. I hit delete and now they're gone. So that is one way of doing this. I also will have kept several versions of the older style over here if I wanted to come back to it. So instead of this moving around with the arrow keys, if I do a select of this and a shift key on the keyboard and then select this over to where I know my material is, I am going to hit it center. So it centers it in the material. So now it's time to start evaluating. What am I forgetting before I go to cut? What's going to happen right here? We're going to get a radius corner. Well, we can't have that because we have a square corner that we're butting this up against. So you can come over to the fillet command and create fillets. So dog bones or T-bones. Depends on what bit you're going to use. I'm going to use a 3/8 bit. So there's 3/8, but I need the radius of it, so I can divide that by 2 and hit equals. And then it's just preference there. I want a dog bone coming in. So there's the dog bones. And there we go. So since I'm kind of using the old file, I know that I've centered it right where the board is already screwed down. So I'm going to come over here and toolpath this. I want to do a profile thickness. And what I want to do here is say, well, I don't remember how thick that Z was. I'm going to go Z plus 0.01, 10,000ths deeper into my table. Now I've got 0.75. And I can select my bit. I got a 3/8 compression. It's up there because that's the last bit that was used. It selects the last bit. You can evaluate how many passes you want. For this, I'd like to do 2 passes in maple versus 1. I'd hate to take a chance of breaking a bit. The way I've drawn this, I want to machine it to the outside versus in or on the line. Tabs. We don't have a vacuum table. How do we keep that from moving around? So I'm going to come in here and put tabs in. And this is a pretty good tab size for this. So you see, if you hit add tabs, it doesn't always add it in the most convenient places. Sometimes it'll put it down here. Sometimes I'm kind of a tab snob, I guess. I like to put them in certain spots where I know I can easily clean them up. I know with the grain, going with the direction of the grain, it's easier to chisel or cut out with a utility knife. I know I can put them right here to my disc sander real quick and clean that up. So, and then another thing I like to add in is a ramp. A nice ramp, nice 6 or 7 inch ramp into this material, and that's just going to let the bit ease down into the board. So profile, shelf, calculate, and do read these messages. I will attest to first-hand knowledge. The time you don't read this, it will say 7.5 versus 0.75. And then just come here into the preview of the toolpath. Make sure you got your tabs. Make sure you're seeing through. You got your T-bones, and then you're ready to cut. I see right there I don't have 3D tabs. I prefer a 3D tab with wood. So I calculate it, and it will change it. I can reset it, preview visible toolpaths, and there's my 3D tab. So, all right. So far we're doing a pretty basic project, but there's a lot to it. There really is. There's a lot of stuff that goes into these projects. All right, so let's go to the next video and see this thing actually cut out. So notice now I'm zeroing over here onto the MDF, not to the tabletop, because I want to make sure it cuts all the way through. Anybody in here today that works with plywood will know exactly what I'm talking about. Plywood has so many different thicknesses. If you zero it to the top, it might not cut all the way through, or it might cut too deep when you go and run it around your machine. Just the way the consistency of that plywood comes these days. Why did I pull that collet and that collet nut apart? Blow them out and then stick them back together. If you have a spindle, no matter what size spindle, that's your process. Break them apart, make sure they're free of debris, spring them back together, and then put them back in. If you shake that thing and the collet flies out of the collet nut, then that spring is sprung in that, and it's time for you to have a new collet. You can check out our video on machine maintenance and learn about what is a good or a bad collet. So I want to zero to the machine bed for this. C2, going in the same spot. Keep your fingers back if you're going to hold it in place. A collet that gets full of sawdust can really throw off a cut, make your bit come loose, make your bit move and down. So the board hasn't moved. We based this off our previous file. So all I had to do was re-zero the Z. So here it is starting to ramp down in. See, it's not a full depth cut right at the beginning. It takes its time to get down in there so it doesn't just do a real throw down into the wood. So if you have hard material, and some bits too are not designed to do that. So this is doing it in 2 passes, taking it easy working with maple here. That 3/8 bit and plywood with an alpha spindle could have ripped right through there. So here it is going to ramp down. Now it's making the through cut. And what's it doing when it picks up and drops like that? It's going to do it right over here on this other end too. And it's just going to pop up and then pop back down. That's the 3D tab. That's why the 3D tabs are real nice. The machine really doesn't slow down. Here we go again. It just makes that nice little tab right there. And there we go. Finishes the tab, and then it goes and cleans out the rest of the ramp. And since all we have used here are screws to hold this thing down, if I was to unscrew this and find something wrong and try to screw it back in, it's not going to happen. Not the way I've got this. I need a fancier fixture or jig. So what I did there was blew some sawdust out and wanted to look down there and see MDF. So the question is, what do you do if you're cutting MDF? Well, you could have put paint or something underneath there, painted the spoil board blue, and then if you see, down in there, if you get it just right, you can. So I'm going to pull the screws out. And there's a couple ways of removing tabs. One is you can hit them with a chisel, or you can nip them out from the backside with the utility knife. Just be careful, you don't try pushing it all out by hand, because you can split the wood. So these here, I probably could have used just a little bit bigger tabs. When I did this, I was a 0.4 and a 0.22. But remember, I cut down into my table a little bit, so that would make the tabs even a little smaller. So there's the tab. I'm not even going to bother sanding that right now, because I'm going to put a routed edge. And there's my spoil board. I cut down into it, anywhere between 10 and 20 thousandths, 0.01 and 0.02. I'd rather cut through into my table than not cut all the way through and then have to sit there with a trim router and clean it up. So, like I said, the way this bit is, it's spinning pretty much 90 degrees from the way it would come in from a planer's cutter head. So it doesn't leave as nice of a finish, but it leaves a finish that is perfectly parallel and flat. And all I have to do is get it back down to that cleaner grain, which takes just a little bit of hand work. And then before I go to the finishing sander, I am going to take and put a ball nose on the end of that board. Yes, I could have put that on the ShopBot and had a round over bit and done it right there, but I'm just doing one shelf. For me, it's quicker to have a preloaded 1/4-inch round over bit that I just run across there versus having to tool path it and change bits. So for one, this works great. If I needed to do 500 of these, and I've got them all glued up into big panels, I try to do them right there with a bit on the machine. And then once you've got it routed, come in with a random orbital, clean up any little burns, and then whatever is left over there from the belt sander. And just remember too, you're gonna after you do this, you're gonna blow it all off, get all the air out of, or the sawdust out of it with your air gun, and then you're gonna finish it. For me, I used Minwax wipe-on polyurethane. I like that stuff a lot. Easy to clean up. It's not really smelly. But remember, the power sanders don't do it all. You also want to get a piece of hand sandpaper, and you want to knock down edges. Yeah, the routed edge is round, and I want to have square corners, but I don't, I'm just knocking them down by hand. And getting that sharp edge off there really helps paint or stain stick to material. If it's a sharp edge, it'll just knock off there if somebody bumped it. So, and then blow it off from there and get finishing. And I didn't think you wanted to see me finish it. So, so just kind of to wrap that up on that one, as we know we tested it with the cardboard. So then after I cut it out and got it finished, I brought it back to my customer, which in this case was Al, and Al was quite pleased and said, "All right, this will hold my printer." So he put it in place and set the printer up there to make sure the printer looked good. And now that printer won't be rocking off the edge. And look at that, there we go. So that is really a fairly simple, custom shelf. But the process behind it, until you've done a couple of them, isn't that simple. There's a lot to it. So I hope this training here was something that was pretty valuable to you and will help you with customers get some of your stuff out there, get your projects out there, and get that ShopBot going for you. So thank you very much.